I am Vishnu CH, currently studying in Sri Venkateshwara College of Engineering, branch CSE CY. Today we are going to talk about the topic Introduction to Additive Group of Integers Modulo N. The additive group of integers modulo n is a fundamental algebraic structure that provides a framework for understanding operations on numbers within a specific range. This introduction explores the key concepts and properties that underpin in this important mathematical construct. First, let us come to the definitions of integer modulo n. First, integers modulo n. The set of integers modulo n, denoted as z divided by nz, consists of the remainders when integers are divided by n. Second, equivalence classes. Each integer in z by nz represents an equivalence class of integers that leave the same remainder when divided by n. Third, arithmetic operations. Arithmetic operations such as addition and multiplication are performed within the modulo n framework with results confined to the range of 0 to n minus 1. Now let us come to the properties of integers modulo n. First one, closure. Addition and multiplication of integers modulo n are closed operations, meaning the result always falls within the set of integers modulo n. Second, associativity. Both addition and multiplication of integers modulo n are associative, allowing for flexible grouping of operations. Third, commutativity. Addition of integers modulo n is commutative, but multiplication is not necessarily commutative. Addition of integers modulo n. Step 1. Take two integers a and b in z divided by nz. Step 2. Compute the sum a plus b. Step 3. Find the remainder when the sum is divided by n. This is the result of the addition modulo 1. Now let us come to the closure property of addition modulo n. Closure under addition. The set of integers modulo n is closed under addition, meaning the sum of any two integers in z by nz is also an integer in z by 1 nz. Proof of closure. If a and b are integers in z by nz, then a plus b is also an integer in z by nz because the results will be congruent to a plus b modulo n. Implications. The closure property ensures that addition of integers modulo n always yields a valid result within the same modular arithmetic systems. Now let us come to the associative property of additional modulo n. Step 1. Take three integers a, b and c in z by nz. Step 2. Compute a plus b plus c and a plus b plus c. Step 3. The results will be the same, demonstrating the associative property of additional modulo n. As you can see, there are some examples using additional property using associative property. Now let us come to the identity element of for additional modulo n. Identity element. The integer 0 in z by nz serves as the identity element for additional modulo n. Addition with identity. For any integers a in z by nz, the sum of a and 0 is always equal to a. Now significance. The existence of an identity element for addition ensures that z by nz forms a group under addition, a fundamental algebraic structure. Now let us come to the inverse elements for addition modulo n. Inverse elements. For every integer a in z by nz, there exists an integer b in z by nz such that a plus b is congruent to 0 modulo n. Second, additive inverse. The integer b is called the additive inverse or negative of a and is denoted as minus a. Third, significance. The existence of inverse elements allows for the cancellation of addends, a crucial property for the group structure of Z by NZ under addition. Now let us come to the commutativity of addition modulo n. Step 1. Take two integers a and b in Z by nz. Step 2. Compute a plus b and b plus a. Step 3. The results will be the same, demonstrating the commutative property of additional modulo n. Now let us come to the applications of additive group of integers modulo n. Cryptography. The additive group of integers modulo n has important applications in cryptographic algorithms such as public key encryption. Second, modular arithmetic. Modular arithmetic operations, including addition, are used in various real-world applications such as scheduling and time calculation. Third, computer science. The additive group of integers modulo n is a fundamental concept in computer science used in areas like digital logic and error correcting codes. Thank you.